but it is the California Energy Efficiency Standards for the state. After his presentation, he will have a question and answer period on that, and I'm going to turn the mic over. And his full bio is on our website, so if you want to hear more of it, I just don't want to read a paragraph to you. I'd rather give you the speaker.
Perfect.
Appreciate it. All right. So go ahead and put that back on. I have a microphone here. Let's see. Can you hear? I don't know.
That's for the Zoom only.
Oh, that's only for Zoom only.
So
Okay.
you got to use that.
Oh, okay. No worries. No worries. All right. So we've got our Zoom, and then we'll speak with this. Okay. Normally I walk around, and but that's okay. We're going to get this. Okay. Can you guys hear me?
Yeah.
All right. Perfect. There we go. We got this here. I'm Bob Douglas. My dad is Bob Douglas. You guys might know Alan. He is up here, and he usually helps get the speakers, I believe, for the different SIRS events. He was in for a procedure on Sunday. He went in for a procedure. They put him under because he had a little nose cancer. So they cut that out, and then they went in. They put him under to try to do the plastic surgery, and he had a heart attack is what happened during that whole process. So, but you know, that guy's like the Phoenix, so he just keeps coming back and everything. So they got him out. They got him in yesterday to do exploratory, and they ended up putting 2 more stents in. So now he's got 15 of them in his heart. So, but he felt great. He felt really good this morning, and he was really hoping he could have got here in time. But unfortunately, you know how hospitals go. He'll probably be there till 5 o'clock by the time they get him discharged out of this place. But no, he wanted to let everybody know that he's doing well. He's really disappointed that he's not here. I know I was supposed to speak, I believe, in September, October, and I think we've been pushing it back as other people have been coming in. So I said, well, I finally get here, and you're in the hospital. But go figure. I mean, he gets to hear me yap a lot, so I think he'll be just fine. Let's see if we can get. I did bring a PowerPoint now. Some of it might be a little difficult to see at times. I don't know if we can expand that into the full thing perfect, and give you guys a little bit of an idea of what we've got going on here. I'll try to explain a lot of it through the microphone as I go through. Essentially, what we're going to be talking about today are the California Energy Efficiency Standards, Title 24, Part 6. And the focus on this today is going to be on non-residential lighting, so basically commercial lighting, because that is where I live in my line of work. And so I don't know how exciting it is. I hope I don't put you to sleep with energy efficiency requirements, but I'll try to make it as exciting as I can and give you guys a little insight into what we have to deal with out there when we're putting these buildings together right now. There we go. I can kind of see that. So we got energy efficiency. SIRS 1110. All right. Hopefully everybody can. Like I said, some of the slides are larger, some are a little more detailed. I'll try to walk you through those as we go. Okay. Go ahead and when we get a chance, we'll go ahead and move on to the next one. Give you a little background on myself. Are we able to advance that slide by chance? Perfect. All right, here's our agenda. So essentially, I'll give you a little personal introduction. We're going to talk about what is Title 24 Part 6. We're going to look at some of the various requirements that are involved with Title 24 Part 6, and we're going to wrap it up with some of the lighting controls that we have to install in these buildings now. Go ahead and slide. All right, one more. All right, so my name's Bob Douglas. I am a Title 24 manager for Sprig Electric. Sprig Electric is one of the Bay Area union contractors. I believe we're probably the third largest behind Cupertino and Rosendin Electric. Redwood City Electric is right in there with us. So we do a lot of really large projects. I myself handle everything Title 24 Part 6 related. So we have pre-permit documentation, we have controls that have to get installed on the job, and we have testing that has to get done. We have state audits and all kinds of stuff that's involved with that. So basically that department sits with me, and I'm able to help with everybody. What's really nice about that is we were acquired by Archkey, the Archkey Group, and Archkey owns, I believe, 3 other electrical contractor companies around the country, and basically just so that we can increase our bond rating and we can go after really, really large work. what was great about that was these other companies are all outside of California. So as everybody in the at Sprig got nervous, going, okay, who's going to get consolidated? Who's going to do this? Well, nobody does Californian lighting controls and all the energy efficiency standards we have here. So it's been really good because I used to be the head of a $330 million a year company. Now I'm the head Title 24 guy for a $1.3 billion company. So hey, go figure, right? And some of those are coming out and doing work. Actually, Sprig Electric is one of our partners, and they are experts in water treatment facilities. So they came out and we bid some work up in San Francisco, the big SFPUC water treatment facility up there, which Sprig Electric never would have done on our own. That is not in our wheelhouse. So it's kind of already opened up windows. If you can go ahead and move forward. So again, I'm part of the IBEW. That's where I get all my training. I did a 5-year apprenticeship and became an inside wireman. Industry experience, I've been in the electrical industry now for 24 years. My experience and my focus has been on lighting for the last 10 years. I've obviously been an apprentice for 5 years. I've been a journeyman. I've been a foreman. And before I went into the office 7 years ago, I was a service foreman for the last 3 years. And I really like that. Personally, I don't like all the issues of dealing with large crews and GCs and all that stuff. I love doing service work because you're left alone and you can just go troubleshoot, fix whatever they want, and get the heck on out of there. But anyway, I do love being in the office now, and with my new role here that I started by doing lighting control design and then eventually took over the whole Title 24 group. Some of my affiliations that I have, I am a California State certified electrician, which is required now in California to work. I'm also an acceptance test technician. In 2013, the state, with Title 24 Part 6, brought in acceptance technicians. And essentially what we have to do is we have to sign off. You have life safety inspectors, which we still have. But now we have energy efficiency inspectors that essentially go through and verify that the aux sensors work and that time clocks work and all that kind of good stuff. So fun times. Let's see, go ahead, next slide. All right, these are some of the projects that we've worked on at Sprig recently. On the left, you can see is the big Uber Mission Bay project. I've worked on all these projects through the design phase and all the way through the closeout phase, which is nice. So that's the Chase right there where the Warriors play on the left, the big white building. And the Uber towers are right there on the, if anybody's been to the Chase Center, those are the two buildings that are like right on the site that have retail stores and stuff, Warrior retail stores under them and whatnot. On the right, we have San Jose Towers. That's a large 2-tower high-rise residential in San Jose that was built a couple years ago. I think we wrapped that up about a year ago, maybe half a year ago. We're really seeing these come to San Jose and to the Bay Area. And we never used to see that when I got in 24 years ago, the high-rise residential. It was really, especially in 332, San Jose, Santa Clara County. Now we're seeing, you know, you look downtown San Jose and you're seeing these high-rise residential popping up constantly. And those are only going to get more prevalent as we go forward. Go ahead, next slide. This is a tower project we're currently working on. This is the Adobe Tower. This is a large project. It's almost $100 million electrical between the core and shell and the tenant improvement, which we have both of. You might be familiar with the two towers, the two Adobe towers downtown. This is across San Fernando, I believe it is. Very large third tower. And if you take a look where that image is being photographed from, and it's a rendering, of course, but that's a bridge. Now that bridge sits, I believe, on the 7th level on the new tower, and then we'll go across San Fernando all the way over to the new to the old twin towers. So everything will be connected through. And I figured I'd give you a little sneak peek. We're currently working on the design of that. If you go to the next slide, this hasn't come out, but essentially this is what that bridge is going to look like. Now, we're doing some design with it and some compliance work with it right now, but it's really going to be cool. It's going to have these trees that go along the top, and if you can tell, those trees completely light up. They're all the different colors of the rainbow. And then if you look beneath, they have like digital roots that connect to the bottom of each tree on the bottom. And those roots, as we call them, will head down and they'll go to the big Adobe sign on the bottom. That all stays lit day and night, kind of like a little art piece that they'll have there. So it'll be really nice looking when that's all done. I don't think many people have seen that. You guys have seen it in the design team, and that's about it. So there you go. You got a little sneak peek in what the bridge is going to look like. All right, next slide, please. All right, so Title 24, Part 6, or Title 24, what is it, right? I mean, a lot of people probably ask, Title 24, what is this? Well, Title 24 is actually all of your different building standards for California. So we've got everything from administrative standards to electrical, mechanical, plumbing. The ones in red that you see, California Energy Code and Part 11, the Cal Green standards, that's what myself and my group deal with. Everything energy efficiency. So, you know, it's nice, it's required, but it's not going to kill anybody if I mess it up, so I have a little leeway with that. Go ahead, next slide, please. All right, so why is it important, or why Title 24 important? Well, it's actually a state law, right? All other building codes, for the most part, are adopted by the different municipalities. Title 26 is a state law that goes across all the municipalities. Now, if it can still be overrun by anything life safety. So life safety inspectors will always be able to override any of this, but it is required and we can't get out of it. And in 2013, when this started, I got a lot of pushback from lighting designers, from architects, from my own, project managers and whatnot. Nobody wanted to adhere to this, but it was very apparent early on that no, this is here to stay and it's not going anywhere. Next slide, please. So what are we trying to achieve here in California? Well, essentially what California is trying to achieve is zero net energy for commercial buildings. And their goal for zero net energy commercial buildings is going to be 2030. So any energy used on that commercial building has to be produced in that building or by that building by 2030. Now, if we're going to actually meet that, I don't know if they're going to meet that, but every 3 years they're ramping up the standards and they're ramping them up in quite large ways to try to get to that point. They also show 50% of commercial building retrofits are going to have to be net zero energy by 2030. So there's going to be a lot of new technology thrown in at these things to get us to that point. Next slide. All right, what projects are regulated? Well, typically new construction, additions, and alterations. These are all going to be covered under Title 24, Part 6 regulations. Retrofits or alterations are hit and miss depending on what they are. Go ahead, next slide. And again, I'm just giving you a little quick overview of Title 24 and then we'll dig in. Building types that are regulated, all building types are regulated in Title 24. As you can see, assembly, business, mercantile, you name it. Prisons are exempt, so if anybody wants to start building prisons, you don't have to worry about energy efficiency standards. And healthcare facilities are limited. We do have to comply from a watts allowed standpoint, but controls are not required in healthcare facilities, although typically they're going to be spec'd out anyway. Next slide. All right, what systems are regulated? Well, Title 24 regulates all these systems of the building. So anything from fenestration, which is like your outer coverings of the building envelopes, covered process, pools, spas, natural gas. You can see the ones in red, lighting controls, electrical distribution, solar ready, and sign lighting are all covered under Title 24, Part 6, and that is what me and my group have to deal with. Next slide, please. Last one with a little overview is what is regulated. What lighting controls are regulated? All lighting controls are regulated. We have what's called Title 20 in California, and essentially all appliances, whether it be your fridge, your washer, or your light switch, or your fixture, have to be regulated through that, and they have certain standards. Most of them are energy efficiency standards that they have to meet to be listed. If they're not listed, they're not allowed to be installed. And as an acceptance technician, that's one of the things that we verify when we're signing off jobs, is that we have listed equipment in these buildings. All right, next slide. All right, so Title 24 has a lot of documentation, right? It's the state of California, right? So essentially you're dealing with the state of California, you're dealing with a lot of regulations, and regulations equals paperwork. And yeah, I like this little slide. It's like, yeah, big misconception. Everyone thinks hell is all fire. Now it's actually all paperwork. And I hate to say it, but Title 24, Part 6, and all this comes with a lot of paperwork that we're responsible for. So let's take a look at some of that. So we have documentation that basically goes through the whole process. I have what are called certificates of compliance. Their NR is non-residential. So we essentially have non-residential certificates of compliance that basically map out the job. So we have to do a takeoff on the job, make sure it complies from an allowed wattage standpoint, and make sure that the controls are going to comply with the allowed controls. Then it goes on the drawings, that goes to building permit. Coming out of building permit, we have to fill out what are called NRCIs. These are construction installation documents. These would be filled out by the foreman or the project manager. And once the project is ready for occupancy, we go for electrical final, and before electrical final, that's your life safety with the inspector. we have to have what's called an acceptance test, and the acceptance technician will go in and he'll verify again that all the energy efficiency measures and controls are working and installed properly. That is how you're going to gain occupancy now for a construction project in California. All right, next slide, please. So this is some of the paperwork that you'll see, okay? This is 4 pages out of our electrical drawing, and this represents a 207,000 square foot tenant improvement. So all of that documentation you see there produced for this one tenant improvement job. What you can see, this job contains indoor and outdoor lighting. On this job, it required indoor documentation, outdoor documentation, and electrical power distribution documentation. So quite a bit goes on there. Let's take a look at close what some of that documentation has. You'll see the one on the left has a lot of your summary statements, so it's going to let the inspector know that the job that it complies, that the allowed wattage is allowed. But they see the one on the right is essentially all the different spaces of the building. We have to list all the spaces of those buildings if we're doing a space takeoff. Each of those spaces is allowed a certain amount of wattage, so we have to, those numbers come from the state. We have to punch in the amount of square footage. All of that computes out an amount of wattage that can be installed in the building, and then we have to make sure that we stick to that. So, you know, we did like that Adobe Tower downtown, the 18-story Adobe Tower. I mean, I think there's about 9 or 10 pages of documentation, just pre-permit documentation, not the construction installation permit documentation, and not all the acceptance testing documentation we have to do at the end. So I tell you, teach your kids to type or something. I tell you, they'll have a career in this thing. All right, next slide, please. All right, so talked about some of the regulations that it sets up through those documents. I'm going to talk about a couple of those things that are set up through those documents. And the first one I want to talk about is right here. This is your lighting power density. So essentially, how we're controlling these buildings is we're only allowing so much wattage to be installed in the building. And everything's based off either the type of building, if it's a whole building takeoff, or we base it off of the room type. So what you can see here is a little progression that we've done. Now, this really kicked into gear in about 2013, okay? That's when the acceptance technicians came on board. That's when all of the really high standards of trying to get this where they want it to be basically came in. Now, I don't list 2013. 13 and 16 were very, very similar numbers because at that time the LED fixtures were just kind of coming up and really getting going. LED fixtures are what are letting us lower these wattage allotments because they're so efficient. The LED compared to what we used to use, we'd always use like the 4-foot fluorescent tubes, typically like a 2x4 with 4 lamps in it. Well, if you got a 32 watt tube, 4 of them, you know, you're talking about 120 some odd watts for each 2x4. Now our 2x4s are usually around 29 or 39 watts, and we get out the same amount of light. So take a look at 2016 in that classroom. In 2016, a classroom was allowed 1.2 watts per square foot. Dropped down to 0.7 in 2009. A big cut. That's where we lost about 30% of our allowed wattage in jobs. And then you can see in 2022, they lowered it just slightly more. So between 16 and 22, classrooms' wattage has been cut in half. And that's pretty much what you're seeing across the board in these. Now, if you sit in a modern day classroom, it's not going to look dark. Again, the modern lighting, the LED lighting is putting out plenty of light to do that. But because that lighting's available, the state is now reducing those allowed wattages, and so pretty much you can't install fluorescent fixtures in a building anymore. You're just not going to comply. Go ahead, let's take a look at the next one. This is our outdoor requirements. Outdoor is very low, as you can see. I mean, 0.025 for hardscape lighting. It dropped down to 0.021 watts per square foot. Very little light, and that's going to drop again in the next code cycle for outdoor. Outdoor lighting, they are essentially wanting your pupils to open up and get the light that way is essentially what they're going to do. They're going to have very, very little light to where they're trying to average just over 1 foot candle on most of these places. So it will not be very bright. Yeah, it's going to be dark in some of these areas that they're going to do. All right, next slide, please. Okay, lighting controls, that's what we got. Okay, lighting control. So how we can achieve all this different stuff? We've got, we've got regulations for amount of wattage we can put in. We also have regulations for controls. Now, controls we're going to go into a little more detail at the end of this presentation. Right here, though, are some of our main contractors or vendors that we use. Watt Stopper. I don't know if anybody's heard of Watt Stopper. Watt Stopper is probably the #1 control system out there right now. Legrand is who owns them. I do a little stock, and if you're interested in that, that's a company I would probably look at. And the only reason I say that is I'm going to talk about some of the changes in the 2022 code for room controllers and the relays that we use to control here, and they're pretty much going to quadruple starting in the next code cycle. Kind of telling everybody, I don't know who to buy in stock, but anybody that sells these electrical controllers, you probably want to have something in them. They're going to have a lot more work, especially if we don't go into a recession. So Watt Stopper is a big one. Acuity Enlight is another popular brand. Enlighted is a very popular brand. That one's used almost exclusively at Apple and Google use those. That was actually a Stanford product, Stanford engineers who came up with that. It's a fully wireless system, very intelligent system. That system, they use it in hospitals to track nursing stations. It can do a lot of things. Temperature, it can track temperature and then tell you, you can map it all out to where your hot spots are, where your cool spots are, so that you can adjust your HVAC controls and stuff like that. Only problem with Enlighted, it's like a typical tech company. They're always looking for the next greatest thing and they're supporting what they already have. And so that's the only issue I've had with Enlighted, is that they're jumping to the next product and they kind of leave us hanging sometimes with some of the other. Douglas lighting controls, I had to throw that in there as a Douglas. I don't know what they are. We've never used them before, but I like the name. Vive is another Lutron Quantum is a very popular lighting system out there in the commercial world. Vive is a wireless one that can be controlled and programmed from your phone. So that's really popular now in homes. People are using those in homes, but we also use them in commercial aspects. Next slide, please. All right. That's another aspect of Title 24 that I wanted to run by you guys, and that is, of course, we have documentation, we have controls, and now we have acceptance testing. So in addition to life safety inspections, we have to do acceptance testing. It's required for all newly constructed commercial buildings and required for most alterations. Next slide, please. This is the CalCTP website, and essentially what we have to do is every job that's permitted in California with lighting gets an acceptance test for the most part. We do the acceptance test. You need those to pass your final with the local AHJ. Once that's done, all those results have to be entered into this state site here. And then the state of California audits us with these jobs. So every 20 to 30 jobs, we get a paper audit. And essentially, they look through my drawings, they look through the documentation, they make sure it matches up, and they ask for $200. and we give them $200. And every 100 jobs, we have to do a physical audit. So for a physical audit, I'll meet Mark or Leslie out there on the site, and they'll go through and they'll make sure the documentation's correct. They'll make sure the occupancy sensors work and the switches work, and they'll charge us $500. So go figure, it's quite a little racket they got there. But hey, it is what it is. It's a state, and it's the price of doing business here. So it is what it is. It is what it is. So that kind of wraps up the CalCTP. So we finished the process of Title 24 with training, system training. Go ahead, next slide, please. Required for all systems, and with these systems, these are programmable systems that are capable of doing a lot of things. They're networked, most of them, so that you can program from a single source. You can retrieve data through that single source. So there's a lot you can do with these systems. So with the big systems, we do have system training. Typically, we'll use the vendors to do this, as they can work them through the actual connections of the system into their internet and all that kind of good stuff. That is not my line, and what I do, I stick to the code, so I don't even want to go down that way. All right, go ahead, next slide, please. So essentially what we've talked about, yeah, you can leave it right here. So essentially what we've talked about right here so far is just a little bit of an overview of Title 24, right? There's a lot to this thing, but essentially it's energy efficiency codes. We know there's a ton of paperwork. We know there's acceptance testing that has to get done. I mean, it's essentially really created a new world for the electrical world, right? I mean, before 2013, you had to have aux sensors installed. That was it. And if they worked, it didn't really matter. I mean, hopefully they work, but if they don't work, nobody's testing those things. They just move on. Like I said, now everything's tested. So what I want to do now is walk you through some of the controls that we're doing on these buildings. And I think some of this is going to kind of blow your mind a little bit. I don't know, has anybody here worked in the construction field and worked on electrical or done anything like that? Familiar with maybe A/B switching and some of the old stuff we would do? So essentially back in the day, you'd have to have a light switch, okay? Most likely, if it was after maybe 1990, you'd have to have an occupancy sensor. From that point on, though, they added things, I believe maybe the mid-90s, A/B switching. So along the windows, they might make you switch the lights along the windows with a different switch. That way, if the customer said, hey, I got plenty of light coming in through the windows, I can manually turn those row of lights off, right, and save a little energy. That was about as far as it went. So what we're going to talk about now is where the state currently is, and I did include some of the 2022 requirements that are going to start January 1st, 2023. That's, if you get a little confused on that, the code's kind of a little bit behind. So the 2022 code starts January 2023. We're currently in the 2019 code, and it's updated every 3 years. All right. So first code requirement we have, all luminaires must be controlled with an on and off switch, right? So every luminaire in that building has to have an on and off switch. Now, there's a couple different exceptions we have, like for night lights, but for the most part, everything has to be manually able to turn on and off. Next slide, please. Now, we have switches. We can't just have a toggle switch, right? Because this is energy efficiency. We have to have dimming also, right? So Title 24 requires that most of these rooms and most of these lights require dimming capability. So next slide, please. And that's typically just a little bit of math. Is your space over 100 square feet? And does the space have over half a watt of light per square foot of general lighting? If it goes, it's getting a dimmer switch. So most conference rooms now, most break rooms, most offices, all of these places lounges are going to have dimmer switches in them. Again, so that the customer has the ability to dim the lights if they want to save some electricity. Now, if any of you are familiar with the old rheostat style dimmers, they basically bled that energy off in heat. So you didn't really save energy, right? Well, Title 20 requires that dimming units save the energy that they reduce in light output. So if this dimmer switch reduces light output by 50%, it reduced light power by 50% also. So that is a big change to the code that they did and what's allowing these dimmer switches to actually save us energy. All right, next slide, please. And if you have questions as we go through this, by the way, raise your hand. I'll also take questions at the end, but if you do, I'm sorry, I should have said it before, if you have a question that's directly related, especially to these controls, let me know. Yes, go ahead. Yeah, they're all digital now. Most everything's digital switches now. They still do a rheostat, but in California, that if it's a required room for dimming, that rheostat wouldn't even qualify. Being that it doesn't, it burns energy essentially as it bleeds off that in heat. Yes?
You mentioned hotspot. They track hotspots?
So the Enlighted system that I mentioned before, that's one of the features it can do, is it can track hotspots. Because it has temperature sensors in the Enlighted motion sensors also have temperature sensors.
So if my hotspot's in the kitchen and she's looking for me somewhere,
you can track that. We can install Enlighted sensors in your house. Now, she'll have a little tag that she has to wear, though. That's the only problem. Have a little tag, and then I'll be able to follow her. Question, yes?
I understand you say that homes would have to be retrofitted to meet the standard 5.
No, this is only going to be for commercial buildings, and only commercial buildings that are going in for permit to have retrofits done. Yeah.
New housing will
probably... New housing originally was supposed to be 2020, was supposed to be net energy zero for single family homes. Now, Sprig Electric, we don't do single family homes. And to be honest with you, we're so buried in different work, I don't even go down that route. We don't do single family. So I don't know if they actually achieved that. I don't believe they're there, but that was their goal. Single family was supposed to be 2020. Net energy zero. But again, this only applies to permitted projects. So if you don't want to do any work on your house, if you've got a business and don't want to update your fluorescent lamps, you don't have to do that work. It's not going to be forced. Or do it without permits. That is absolutely.
If you just take light bulb, you're good.
So this typically is what I'm talking about today. Mostly applies to new construction. It does apply to certain tenant improvements, though. If it's a permitted tenant improvement and you're increasing lighting load, then it typically kicks in all the current requirements. If you're not increasing lighting load, they do have some ways where you can basically relocate lights and leave them as is. Yeah, the state has that. All right, so let's take a look at this. We just talked, go back one slide if you would. We just talked about manual switches. Then we talked about the dimming requirements. The next one we have, and they get a little more extreme as we go, so they'll get a little more fun as we go. We have auto shut-off requirements, right? So all installed indoor lighting must have controls that automatically shut off all the lighting. Now, we already said that they all have to have a manual switch. They also have to have automatic means of shut-off. Now, we can do this with two ways. We have occupancy sensing controls that can be used, and we have time clock controls that can be used. Now, time clocks are limited. You can't use them in every space. Certain spaces have to use occupancy sensors. And again, there are exceptions for electric rooms and for night lights. Night lights, typically, and those are along paths of egress, stairwells, corridors, things like this. Okay, these are things that essentially can stay on. The other one is electric rooms, right? And electric rooms becomes a life safety. It's automatically shut off an electrician when he's maybe in a hot panel swapping out a breaker, and then boom, all the lights shut off on him, and he's kicking his back leg trying to get the motion sensor to kick back on, right? Not what you want to be doing. Not that we should be working on hot here, but anyone who works in that field knows that as an electrician we do hot work sometimes, so it is what it is. Next slide, please. All right, what I wanted to do was walk you guys through what the different types of aux sensors. These are now required for certain types of installations, certain types of spaces. We have 4 different types of occupancy sensor settings. The first one is just your standard occupancy sensor. This is where you leave the room. When you vacate the room, all the lights turn off. When you enter the room, all the lights turn on, right? Pretty simple, pretty standard. Now, next slide, please. We have another type. This is called our partial on occupancy sensors. And again, each one of these are required in different situations. We won't go into all that because, again, I do hour classes every 2 weeks, and they last for like 6 months. I can keep you guys busy for a long time if you want, but probably bore you. Partial on automatically turns lighting off when you leave or vacate the space. Now, when you enter the space, only part of the lights are going to come on, okay? And we're doing this typically in conference rooms, offices, things like that now. Now, to get all the lights on, you're going to have to manually turn them on. So you walk in the room, one of the 5 lights turns on, you go over and you manually turn the rest on if you want. Again, they're hoping that maybe you went in and just forgot some paper. You went in, you grabbed the paper off your desk and you leave, and guess what? You never turned all 5 lights on. This is kind of how the state's looking at this, right? They're looking at any way they can collectively save energy, and it all starts to add up. Next slide, please. Next one we have is what we call a partial off. Now, partial ons, again, we're like conference rooms, and these partial offs are going to be in stairwells and corridors. So when you leave a stairwell or corridor during typically occupied hours, meaning the working hours of the building, that is not going to go all the way dark. That corridor or stairwell will leave some light on for you. Now, when you enter the space, all the light's going to go on. Again, when you leave 20 minutes later, because that's the code, 20-minute timeouts, we're only going to go partial off. Next slide, please. And this one creates always a lot of confusion. Vacancy sensors. Everyone's like, well, what's a vacancy sensor? Well, vacancy sensor essentially acts the same as all the other sensors when you leave. You leave the space, all the lights turn off. But the thing about a vacancy sensor is when you enter the space, the occupancy sensor picks you up and does not turn any of the lights on. Those are meant to be turned on completely manual. The code allows us to either do partial on or vacancy sensors for, I won't get into all the details, but certain applications, we never do vacancy sensors because all we get back from customers is, my occupancy sensor doesn't work. Nothing ever turns on, right? At least if you do partial on, they understand that, hey, it picked me up, it only turned part of the lights on. If it doesn't turn any lights on, typically the customers just get angry and tell you that your system doesn't work. All right, next slide, please. All right, this is a fun one. So this is an open office that I'm showing you here, and if you can tell, there are 6 F1 linear fixtures that go from top to bottom. Now, I drew a red circle around all of them that shows 2,000 square feet, and then I showed 3 different zones that are just slightly under 600 square feet. This is a new code requirement for 2022, and this is the one that I was talking about that is going to literally quadruple our amount of relays and room controllers that we have to purchase on projects. What the state has done is essentially said that open offices or offices over 250 square feet now have to be controlled with occupancy sensors in control zones no larger than 600 square feet. So at 600 square feet, all the fixtures that sit in that zone have to have their own occupancy sensor that only controls those lights. Yes, we used to be able to go up to 5,000 square feet. So we could do a huge open office like at Adobe, and essentially all of that open office, 5,000 square feet, would be on one relay. So all the lights would come on and off together when you walked in the room. When you go to that same 5,000 square foot open office now, you're probably going to have about 10 relays. And each one of those zones will come on individually as you walk from space to space. Go ahead and let's look at the next slide, and I'll show you kind of what this looks like in plan view, or what this would look like in the electrical drawings. So as you can see, I've got a Z1 fixture. I've got an F1 fixture. And the two fixtures on the left are circuit 6, and the switching zone is A. So all of those fixtures can manually switch with switching zone A. And you'll see my light switch A is up at the top right corner. But from an auto shutoff perspective, I cannot have all those fixtures turn on and off together with occupancy. They have to be broken up. So the two left fixtures are 6A, which is your switching zone, and then there's zone 1, Z1, which is my occupancy zone. And those are signified with the two occupancy sensors in that group that are called Z1. You can see right next to it, you got Z2, and over next to that, you've got Z3. So yeah, quite complicated. Real quick, go ahead, next slide, and I'll show you kind of what this looks like as this walks through. All right, so here's I've got a 2,000 square foot open office. I walk into the corner of my open office, zone 1 goes to 100%. The other zones will go to 20%. They can't get 0, but the code does allow them to go to 20%, because if you have a really large open office and you're working in your cube and everything else around you is dark, it's kind of a little unnerving, maybe going to creep people out. Yeah, so that's why the code said, no, we're going to allow those to go to 100%. But as you can see, the zone I'm in is at 100. Everything else is at 20. Next slide, please. I walk into the next zone. That zone goes to 100. Again, the other zones stay at 20. Next slide, please. And as I exit, everything turns off. So that's essentially what we're having to do. And like I said, we had, I think the Adobe project is roughly, I want to say 40 to 80 room controllers per floor. So this would have made the Adobe project probably around 200, 240 room controllers per floor. But that's what I'm saying. I mean, whoever wrote that code, they had something to do with the vendors. Next slide, please. All right, let's take a look real quick at daylighting requirements. So, we got a question? Yes, sir. Yep. Great question. So currently, typically if they're set up right, no, they shouldn't, because we install typically dual sensors. So you have PIR sensors, which is looking for more major movement. Then you have ultrasonic. And ultrasonic can pick up a little better. They have microphonic if you're talking about it. Now, to your question though, if it's set up properly and it's spaced properly, yes, you should always have, even typing should be able to keep the lights on. It's going to get thing. Ultrasonic sensors, you can't really keep them in a zone. They just kind of wander. They'll go around corners. They'll do things like that. When we have to keep these zones located or stuck at a 600 square foot zone, we're going to not only have to put probably just PIR only sensors, but then we're going to have to tune them down, really tune them down so they're not extending out 35, 40 feet and picking up people in the next zone. So yeah, I wouldn't be surprised if you have a couple hand waves at your computer going forward to get your lights to come back on. Now, hopefully you have multiple people in your zone and somebody's moving and stuff, but it does come up. It's a great question. Yeah. One more question, okay? You're talking LEED standards, LEED? Right. LEED, yeah, okay, yeah, so LEED. So I cover LEED in my group too, and essentially LEED is just like it's a set of standards that you can opt into. They're not required. Essentially, a lot of buildings will try to gain LEED status, whether platinum, gold, silver, whatever it is, and they have certain standards for buildings that they have to build to from an energy perspective. If you meet all of the top level thing, you get a plaque. If you ever go into a building downtown, especially a newer building, when you walk into those buildings, look around the door when you enter. A lot of times there's a plaque there, and that plaque says LEED Platinum Certified or LEED Gold Certified, something to that effect. And essentially what that's telling you is that building was designed from an energy perspective. If it's platinum, that means that building it's net energy zero. It is that building is very energy efficient. Something like you might see at the Google Charleston buildings out there by Shoreline. Has anybody seen those really fancy buildings out there? Those are state of the art. They are state of the art. Yeah, so that does have to do with LEED. Yeah, no, I wouldn't be surprised. Most all the cities have what we call reach requirements now. So I didn't go into reach requirements because again, I mean, we can go on and on and on. But yes, reach requirements are what each individual city now is putting together. Perfect example of a reach requirement for San Jose is the code, I think, requires 6% of your parking spaces to be EV capable for new construction. San Jose is going to ramp it up to, I think, to 40. So for the reach require 40, yeah, huge. That's why the code has created new code language for services, because we need new services that are strictly just for car charging. And so yeah, it's really changing. But yeah, you'll see some of those lead requirements. Cities that can mandate certain lead requirements for commercial, residential, anything. Yep. Yep.
Can you destroy your house and move to Texas to get it out of that?
You can sell your house and move to Texas. I wouldn't until Google takes over San Jose. Personally, I'm not going anywhere until Google takes over San Jose when my home triples in value. Then I might move to Texas. I would also buy a generator because Texas, of course, we know has some electrical and power issues out there anytime it gets hot or cold. So you might want to take care of that.
Mentioning generators, do all these standards apply to all the nuclear power plants that are going to be coming online in California?
You know, so what I'm dealing with, yes. Yeah, so what I'm dealing with, yes. When it comes to life safety for a power plant, yeah. Yeah, but absolutely, no, they would though. I mean, if you've got lighting, they've got requirements. Let's take a look at these daylighting requirements real quick. Next one here. All right, so essentially what we've done now is we've broken these offices into 4 different zones. You have a primary zone, and that's the zone that sits right against your windows. You have secondary, you have tertiary zones, which are away from the windows. So these are areas that don't get offset by natural sunlight. And then, of course, you have skylit zones. All of these have to be accounted for and controlled separately. Let's take a look at how we do that. Next slide, please. So essentially what you're seeing on those zones is this. We've got the window on the right. You can see the person standing there. You can see a 2x4 fixture almost over their head. As the daylight comes in, you can see that the primary zone right against the window, that's going to have a lot of daylight. So that fixture is going to go to a 30% output. Those fixtures in those zones are going to be reduced to 30% when the sunlight's in the building. When the sunlight goes to the secondary zone, you'll see that fixture might drop to maybe 60%. Now, these aren't fixed values. We program those in depending on every job's a little different on the values because we're trying to basically match the design foot candle levels. But anyway, that's essentially what you're seeing from a side view of this daylighting and how it works. So the further in the building you go, the fixtures won't dim at all because they don't get offset by daylight. But the fixtures right along the window, they're automatically going to be dimming. That's a big part of this. This is all automatic. It's no longer manual, right? Before we had A/B switching along the windows, that was manual. This is automatic. The customer has no choice. It's going to be dimming whether they like it or not. Go ahead and move to the next one. So this is what you can see, and this is pretty complicated here. You can see we have 2 linear fixtures, okay? These are on circuit 6. The switching zone is A, so the manual switch is going to be switch A for both fixtures. But you see the bottom fixture? That one goes through a primary zone, and that's what the DL1 designation is. It goes through a secondary zone. Again, that's this DL2 designation. So that part of the linear fixture against the window, it's going to only be at 30% output. The DL2 part of that linear fixture is going to be at 60% output. You have a small section in the tertiary zone that won't have any dimming due to daylighting, and now you have a skylit section that goes under that skylight that's going to be controlled by a skylight sensor. This is the kind of stuff we deal with. And each one of those has to be, again, dimmed separately. Go ahead to the next slide and you can take a look at the controls involved in controlling something like that. So this is what the controls will look like. You're going to have 2 room controllers. The one on the left is 3 relays. Again, we're tying all the relays together because these lights all switch on and off together manually. But they have to dim separate. So they all of those sections, the red, the pink, the white, and the blue, all get separate dimming wires to them. So we have 2 sets of dimming cables that go to each one of those sections. And then that all has to be programmed because here's the thing. When you manually dim your fixtures, all those dim together. But then when the daylight sensor comes into play, it has to individually dim the section. So it's really complicated, and again, it's done through programming. So I mean, we don't. But you can see this used to just be a 2-wire. 10 years ago, we'd run a 2-wire, hot and neutral to that thing, put it on an aux sensor and call it good. This is now what a linear fixture looks like in these buildings. And so you can imagine the increase in labor costs that go into something like this. Oh, you could have it, and yeah, you can have that, and then you have lighting designers, of course, that come in, and the lighting designer looks at his linear fixture, and that's 30%, this is 60%, this, and they're mad as heck because they're like, that's not the look I'm going for, and it's like, well, that's the look California is going to give you. So anyway, so that's our daylighting controls. Next slide, please. Yeah, we got a couple here, and then we'll be done. Automated demand response, again. This is load shedding that we have to do for all buildings. So essentially what you can see here is we have a peak amount of electricity that ends up right at the top of that arrow, or top of that diamond peak. That's what we're trying to cut off. So load shedding is essentially where the utility can come into your business and automatically reduce lighting power by 15%. So that's going to happen when the grid gets overwhelmed. Next slide, please. And that applies to big offices. Now you can opt in and out of those, and you do get money if you do those. Next slide, please. Controlled receptacle. You guys ever heard of controlled receptacles? Well, there you go. Now your receptacle doesn't stay hot all the time. When you leave the office, they shut down. When it's the weekend, the receptacles are shutting down. Now, not all of them for every office, but half of them. And so, of course, what do the customers all do? They put tape over the controlled receptacle and say, don't plug anything into that one, because that thing keeps shutting off all the time. But it is required, and this is not going anywhere. Next slide, please. You know, that's a great question. The installed upside down, it's not a code requirement. It is a safety thing that some people have felt that it's safe, so you can't lose something, but it's not a code requirement. Yeah, what? Well, that way your ground's on top, so if anything fell, it would hit the ground, and it wouldn't go across the two phases, or wouldn't go across the hot and neutral. But it's not a requirement. Last thing I'll talk about is outdoor requirements. All outdoor lighting has to be shut off with photo control or time clock. Next slide, please. It also, though, has to have motion control. So any fixture that we install over 40 watts is going to have motion control. So that parking lot on the left is with nobody in it. Once you drive into the parking lot, boom, they're all going to go to full bright on you. So again, these controls are for indoor, outdoor, you name it.
So what if you set up your office, your building, and then 10 years later, somebody sets up a 20-story building next to you?
That's fine.
That will change all the sunlight.
That will change the sunlight, but your sensors adjust to the sunlight. So if you block the sunlight, then the sensor will never trigger anything. And I believe that's it. Next slide, I think, is it. That's it, folks. All right. Yeah, exactly. Yeah. Hey, let them know I'll stick around for questions, and I have business. They wanted to take one if they have.
Can I have your attention before we discuss? Bob will be available after the meeting closes. He has business cards in the back. If you have additional questions, he'll be sticking around so you can answer. One last thing for our press before is our attendance drive.
You should invest in.
Please dig deep and grab something. Ron Gaunt.
What did I do?
Ron,
You won.
you attended and you're here. Come get your prize. Thank you.